Hello, my name is Gerald Herwood and I'm a Senior Microsoft Specialist Solutions Architect. Presenting with me is a Principal Microsoft Special Solutions Architect, Siavash Irani. We will be showcasing various strategies for migrating Microsoft workloads to AWS. In this session, you will learn the recommended patterns when migrating Microsoft SQL, .NET, AD application workloads. To see some patterns in action, Siavash created a short demo to provide you insight into a practical implementation example on migrating workloads. With that said, let's get started. Migrating large-scale workloads can be challenging. To simplify the process, we've defined different phases for your migration journey. There are 3 phases in our approach to complete the large-scale migrations. Once you've completed your migrations, the next thing to do is optimize your migrated workloads. In the first phase, we conduct an assessment. This is where we build a business case and perform a cloud readiness assessment. Listed are various assessment types. Second is a mobilization phase, in which we build an AWS architecture and migration plan that is used to mobilize businesses to migrate at scale. Third, basically, is a migration and modernization phase, where we first enable customers to move workloads to AWS and then partner with the customer to basically implement optimizations for business benefits. In this session, we're going to focus on the migration and modernization phase for Microsoft workloads. When we evaluate customer Microsoft workloads, we tend to see some patterns. In this next section, I will be walking you through patterns and options when migrating identity managed by Active Directory, SQL Server databases, and .NET applications. First, let's talk about different options and patterns for migrating Active Directory to AWS. There are different patterns that customers follow to migrate their Microsoft Active Directory to the cloud. Here, we will be covering 2 of the most common use cases. The first option is self-managed Active Directory on EC2. This option requires customers to promote their domain controllers to EC2 and then manage it themselves. The second option is to use AWS Managed Active Directory, in which AWS manages Microsoft AD on behalf of customers, offloading the effort of managing the infrastructure. It also provides the integration with other AWS services. Let's drill down into each option to show you how they can be used to fit customer requirements. With self-managed Active Directory on EC2, you will create Windows Server EC2 instances and then promote them to domain controllers. You can promote them to additional domain controllers for your existing domain or create new Active Directory domains. You will be required to build proper network connections between your on-premise facility and the cloud, which can be accomplished by different technologies like AWS Direct Connect or site-to-site VPN. Customers usually deploy domain controllers in different availability zones for high availability or in multi-regions for added protection. Customers choose this approach to have the ability to extend their on-premises domain using the same schema, users, and configuration to their cloud domain controllers deployed on EC2. Since you are building and establishing trust as well as installs and configure applications like Microsoft Exchange that require full domain administrative privileges. And also, one other point too is with this, you get the benefit of basically operating this, operating your Active Directory yourself, which gives you full administrative access to the domain. When you launch AWS Managed Microsoft AD, it creates a highly available pair of domain controllers connected to your virtual private cloud. The domain controllers run in different availability zones in a region of your choice and have monitoring, automatic recovery, data replication, snapshots, and software updates automatically configured and managed on your behalf. With AWS Managed Microsoft AD, you can run directory-aware workloads in the AWS cloud, including Microsoft SharePoint and custom .NET and SQL Server-based applications. You can also configure a trust relationship between your on-premise and AWS Managed Microsoft AD, providing users and groups access to resources in either domain using single sign-on. Additionally, you can take advantage of basically your seamless domain join feature of our seamless domain join features to join your EC2 instances to the AWS Managed Microsoft AD when created. For the use case where AD is deployed across region, AWS Managed Microsoft AD offers the ability to replicate your directory across regions to increase your availability. Let's transition to learn various SQL Server migration patterns. To set the stage, there are different patterns to run Microsoft SQL Server on AWS. The first is configuring Microsoft SQL on EC2 instances. In this case, you install a SQL Server on a Windows instance and manage backups, maintenance schedules, and patching of the SQL Server and operating system. For the benefits of this option, it gives customers full access to the operating system and SQL database. Additionally, customers can bring their SQL Server license to the cloud and also the choice of installing their SQL database on Amazon Linux, Red Hat, or Ubuntu operating systems. Another option is to run Amazon Managed Relational Database Service, or RDS, for SQL Server. Amazon RDS for SQL Server makes it easy to set up, operate, and scale SQL Server deployments in the cloud. With Amazon RDS, you can deploy multiple editions of SQL Server in minutes with cost-efficient and resizable compute capacity. Amazon RDS frees you up to focus on application development by managing time-consuming database administration tasks, including provisioning, backups, software patching, monitoring, and hardware scaling. Now that we've established how you can run SQL Server on AWS, I would like to talk about different paths and tools that help with SQL Server migrations to the cloud. The first we offer is AWS Database Migration Service, which migrates your Microsoft SQL data. Next, we offer AWS Application Migration Services to enable you to migrate your entire virtual machine. Lastly, customers can leverage native Microsoft SQL features like backup and restore, log shipping, and distributed availability groups, which helps with migrating the SQL database. First, let's talk about Database Migration Service. Migrating databases can be challenging when moving from on-premises to the cloud or from one relational database engine to another. AWS Database Migration Service, also known as AWS DMS, is a cloud service that makes it easy to migrate relational databases, data warehouses, NoSQL databases, and other types of data stores. During a migration, the source database remains fully operational, minimizing downtime to applications that rely on the database. To perform a database migration, AWS DMS creates a DMS replication server which connects to, reads, and formats the source data for consumption by the target data store, and then it loads the data into the target data store once done. Most of this processing happens in memory, though large transactions may require some buffering to disk. AWS DMS supports as a source a variety of Microsoft SQL Server versions, things like from SQL Server 2005 to SQL Server 2019, and different editions like Enterprise, Standard, Workgroup, Developer, and Web editions. AWS DMS also basically allows ongoing replication for SQL Server, which uses native SQL Server replication for tables with primary keys, and change data capture, CDC, for tables without primary keys. The second migration path is Application Migration Service, or AWS MGN. Use cases that require migrating a Microsoft SQL Server VM, its operating system, database configurations, and data storage can be challenging. Customers have to coordinate a migration period that does not impact the business, along with configure networking to accommodate the bandwidth and connectivity requirements to the target location. AWS MGN helps you simplify, expedite, and automate large-scale migrations to AWS. To migrate your VMs, you need only to install an agent on each VM and then use the AWS Application Migration Console to define your replication settings to replicate your Microsoft SQL instances. Later in our presentation, we will demo creating a replication of an instance using the AWS Application Migration Service console. Thinking a bit more, what about use cases to migrate your SQL Server using native tools without relying on third-party tools? For this use case, you can use SQL Server Distributed Availability Groups. The native SQL Server service enables customers to replicate their database to the target location with no impact to the primary node. You can use this strategy as a means to conduct a lift and shift or for scenarios to seed a disaster recovery or multi-site deployment. When planning your migration, you configure the Distributed Availability Group and begin the data replication. Keep in mind that initially, Replication will be asynchronous to not impact applications that are still relying on the on-premises database. When you get close to the cutover time, you stop all data traffic to the original availability group, and you set the distributed availability group replication to synchronous. This action ensures that the primary replica of the second availability group is fully synchronized. After you've verified the synchronization, then you can fail over to the secondary availability group to complete the migration. Let's transition to learn various .NET application migration patterns. There are different patterns and platforms to run .NET applications in AWS. First is rehosting, also known as lift and shift, to migrate applications to Amazon EC2 instances. Second is replatforming, in which you might make a few cloud or other minor optimizations in order to achieve some tangible benefits. And those tangible benefits you want to do without changing the core architecture of the application. For example, you may migrate your application to a fully managed platform like Amazon Elastic Beanstalk. Or if your application is container-based, you can run it using AWS Elastic Container Service or AWS Elastic Kubernetes Service. Third is a refactoring or re-architecting phase, which is reimagining how the application is architected and developed, typically using cloud-native features. This is usually driven by a strong business need to add features, scale, performance that would otherwise be difficult to achieve in the application's existing environment. For example, when you move from a monolithic application to a serverless design based on AWS Lambda. Continuing on, when developers attempt to replatform their Windows web applications to managed services like AWS Elastic Beanstalk, they sometimes face challenges. To help, we have built Windows Web Application Migration Assistance, which is an interactive PowerShell script that migrates websites and their configurations to AWS Elastic Beanstalk. The Migration Assistant is available as an open source project on GitHub and can migrate ASP.NET applications running on .NET frameworks and also on .NET Core. It'll help you migrate an entire website and its configuration to AWS Elastic Beanstalk with minimal or no changes to the application. This increases developer productivity and reduces IT operation overhead. Here's an overview of the Migration Assistance workflow. Let's assume you have a web application running ASP.NET or ASP.NET Core on premises. When you run the web application Migration Assistant PowerShell script on the IIS server, the script automatically discovers and lists any websites hosted on the local IIS server. Then, you choose the websites that you wish to migrate. The script checks selected websites, web.config, and iterates through its connection string settings. You are then prompted to update connection strings to have them point to the migrated database instance. From there, the script generates an Elastic Beanstalk deployment bundle. The bundle includes web application binaries and instructions for Elastic Beanstalk on how it should host the application. Finally, the script uploads the deployment bundle to the Elastic Beanstalk application for hosting. Once the application is migrated to Elastic Beanstalk, you can have different versions of your application for different environments like test and production. Containerizing your .NET Framework and .NET Core applications can be challenging. AWS Apt2Container is a command line tool for modernizing .NET and Java apps into containerized applications. Apt2Container analyzes and bundles an inventory of all applications installed on the VM. It can analyze VMs running either on-premises or in the cloud. You simply select the application you want to containerize, and Apt2Container packages the application artifact identified and along with identified dependencies into container images. It also configures the network ports and generates the ECS task or Kubernetes pod definitions. Apt2Container is purpose-built for converting an entire website, making it easier to containerize .NET applications with minimal or no changes to the application. Let's see how Apt2Container works under the hood. Let's assume you have an application server running Microsoft IIS. When you run Apt2Container via PowerShell, it discovers and inventories all IIS sites capable to be containerized. Once inventoried, You now can select the IIS site that you want to containerize. From there, app2container analyzes dependencies and the IIS configuration. As an optional step, it allows you to update any database connection strings required. Now you're at the home stretch. From this point on, app2container extracts all necessary artifacts to containerize the application. Once the artifacts are ready, they are uploaded to an Amazon S3 bucket. From there, you can build and push the container image to Amazon Elastic Container Registry or register as a task in the Amazon Elastic Container Service. It also allows you to generate a deployment file to deploy your container to our Elastic Kubernetes service. We all know that Windows Server 2008 and 2008 R2 have reached their end of support in January of 2020. However, we also know businesses still rely on legacy applications which are only compatible with these older operating systems. Customers ask, how can we migrate to the cloud and run these legacy applications to a supported operating system without making any code changes? Our recommendation is to use the End of Support Migration Program, or EMP, for Windows Server. It is purpose-built for packaging legacy applications and migrating them to run on newer Windows Server operating systems without making any code changes. To get started, you download and install the EMP compatibility package media on the instance you intend to migrate. EMP will perform an application discovery and intercept API calls made to the OS and will build a package of all the components your application needs to run. It has the ability to resolve all incompatibilities while maintaining the complete application behavior as it is by using features like redirection to intercept Windows API calls as the application interacts with the local operating system, or things like isolation to run older versions of runtimes. Lastly, it has a compatibility feature which resolves OS incompatibilities while maintaining integration with other versions of applications and services. This high-level architecture diagram illustrates how AWS MGN can deliver rapid and reliable migration with minimal business disruption to your Windows workloads. On the left is the source environment, which can be your on-prem infrastructure, comprised of different types of Windows applications and Microsoft SQL Server databases. The staging replication servers are lightweight Linux servers whose role is to block-level copy data for your on-premise instances and stage them on AWS. You'll notice on the right-hand side are your target instances that were copied and staged by AWS MGN. At the time you're ready to launch, AWS MGN starts your instances in a target environment for you to access. Implementation begins by installing the AWS replication agent on your source servers. This does not require a reboot, nor does it impact system performance in any noticeable way. Once you've installed the agent, you can view and define replication settings for your service on the AWS Application Migration Service console. With that, I'm going to now pass it on to Siavash to demo AWS MGN.
Thanks, Gerald. Here I am going to demo AWS MGN. This service gives you ability to migrate various virtual machines to AWS. And for this demo, we have a two-tier web application on premises, which we want to migrate to AWS using this service. In this case, I have a sample application which is running PHP, and the PHP is running on this IIS server here. And basically, this you can see the IIS website there. And this IIS website is connected to a backend SQL server, which you can see the data and in the database for that PHP application. Now, to be able to migrate these servers, first I need to add them to the application migration service. From the application migration service, I'm going to click on source servers, and here you see when you click on add servers, it's going to take you to a documentation page which gives you the installation agent URL. So you install this agent on the instance, and that agent starts replication to your AWS console. I've already downloaded the replication agent on both servers, and here I'm going to open a PowerShell and run the agent in the PowerShell. Once I execute the replication agent, it's going to first prompt for the region that I want to install, basically do the replication to. In this case, I'm going to choose US East 2. And then it also requires an IAM access key and secret key so it can authenticate with my AWS account. In this case, I've already created an IAM user, and here I'm going to provide the access key and secret key so the replication agent can start block level replication to the application migration service. Also here, I need to choose the drives that I want to be replicated. In this case, I only have one drive on this box. It's only C drive. It's a 30 gigabyte volume. And I'm going to just choose that one. And then once I do that, I'm going to do the similar task on my SQL Server. So we're going to fast forward the video so you can see how it's done on the SQL Server. And the only difference with the SQL Server is it's a 50 gigabyte volume. Now, after that's done, if I come back to a application migration service console, you can see that the both servers, the IIS server and SQL Server, they both show here. And initially, it does a initial sync, which normally takes a little while, to replicate all the volumes. And once the replication is finished, both instances will become ready for testing. And you can see here, how long it took for replication of each volume of those servers to take. Now, what I want to do, and you can see that, for SQL Server as well here, that was like 50 gigabyte and, it took 93 minutes to do the replication. And remember, right now the servers are still being replicated in the backend in a continuous way. Now, what I want to do next, since the servers are, fully replicated, I'm ready for testing. But before testing, I want to come back to my source application and just enter a random entry in my application, like Coffee Dark and enter a price. This is so, after what migration, we can make sure that even the latest changes to the app has been migrated to my AWS account. So next, what I'm going to do here, I'm going to choose both servers that are ready for testing. And from test and cutover, click on launch test instances. What this is going to do is it's going to launch EC2 instances in my account based on, the replicated volumes. And once it should also capture all the latest changes that was made to the app. Here you can see the status of the job. It's going to take a while, until it maps all the volumes to instances that it creates in EC2. And once the job is finished, you can see now that we fast forward the video so you can see the job is done now. And once the job is finished, you can see the EC2 instances that's been created for SQL Server and also IIS Web Server in my account. Now I'm going to go back to EC2 console, and you can see the IIS Web Server EC2 instance that's created and also the SQL Server that's created. And also notice that AWS Application Migration Service replication. This is the replication server which we use in the staging environment. And it's a small Linux box which only is used to replicate the source volumes. You can see the 30 gigabyte volume is for my IIS, and then that 50 gigabyte is for my SQL Server box. And of course that 8 gigabyte is for my for the Linux box itself, which is running the replication software on it. Next thing I want to do is I'm going to connect to my IIS Web Server public URL. And I want to make sure that actually my application works and test the application functionality. So here I'm going to open a new tab, and then I'm going to enter the URL for my application. And here we should be able to see that last entry that I entered in my application right before the doing the testing. So that means my testing was successful. And what I'm going to do here is next step, I'm going to come here and mark the servers as ready for cutover. Basically, I did the test, it was fine. Now I want to do the cutover. Once I click on this, it's going to ask me to terminate the test instances that were launched during, testing, and that's fine because we will launch new cutover instances. With this, now you can complete the migration using the Launch Cutover Instances option from this menu. In this demo, we showed you how you can use AWS MGN to migrate a sample Windows Web application to AWS. I hope you found this informative, and with that, I'm going to pass it back to Gerald.
In this session, you learned various strategies for migrating Microsoft workloads to AWS. To continue on in your learning journey, please visit awsamazon.com/windows to get more in-depth knowledge. As a key takeaway, remember that you can accelerate your migrations by leveraging the AWS Application Migration Service to establish early wins. And keep in mind, modernization of your .NET applications can be the key to unlocking the true potential of your business. So you joined the summit to learn, and you keep learning beyond this event. Accelerate your professional development and transform your business with resources from AWS training and certification for you and your teams. We offer a variety of digital training, classroom training, white papers, and guidelines that help you to learn successfully and migrate your existing applications and workloads to the AWS cloud, and also build and develop your professional development with cloud roles. For more information, visit aws.training and see what resources are available to help you achieve your goals. We've really enjoyed presenting to you, and we hope you will take the time to provide feedback. We listen to our customers, and we want to know what topics matter to you. Thanks for watching.